Okay, so the last two questions are applications. They're actually fairly gentle. They'd be good ones if I was to pick what I'd like to see for an applications question. 48,000 liters of water in the first month, and it decreases by 6% for each month after that. So if it decreases by 6%, how much is left over? 94%. So we have a common ratio with 94% left over each month, and I have a first term of 48,000 liters. So that means if it runs dry, you pump this well, you flick the switch, and you walk away. You let it run forever. So that means the infinite sum will tell me how many liters of water is in that well. And that's 48,000. So it becomes 800,000 liters of water. Okay. And finally, the bouncing ball. So what would a applications section be without a bouncing ball? Okay. So before I do much of anything, I'm going to draw a good picture. And it says it's dropped from 5 meters, so that's where I start. I know I have 5 meters of height here. It rises to 60% each time. So maybe I'll just label a couple of pieces so I can see the pattern. What's the total vertical distance before it comes to rest? So before it comes to rest, again, this means we're waiting for that ball to bounce an infinite number of times. We want to add up all these little heights. Okay? We fall, rise, fall, rise, fall. So the only time that I don't end up with both is the first time. It never happened here. So what we discussed in our lesson on this was it's like I have twice the infinite sum, but then I've added this black arrow here which doesn't belong. So what I have to do is subtract that black arrow, and then I only end up with the picture like it's supposed to be. So for this scenario, it will be 2 times 5 over 1 minus 0.6 minus 5. Which is 20 meters. Okay, so that was rapid fire. That was pretty fast. So I'll post this to YouTube if you'd like to review it, because I apologize for the speed that we did have to move at.